before we head to the next page, I want to ask something. All right, now, I would need your 100% of your attention. 100, not 99. And I need your 100% of your honesty. Do you know this or do you not know this? Okay. Are you 100% comfortable? Not 99%. I need you to be 100% comfortable in answering these questions. Okay. Now, back in term 3, I said that these exponent properties will come back. At the time, it's now. It's back. And also back in term 3, I said that you need to know your properties and you need to know the justification of your properties. Because if you don't know your justifications, then you're going to lose them. If you are less than 100% comfortable, let me take a wild guess. You didn't learn how to justify these properties. And this is not just for these properties. I want you to know this. It's about how you learn things. Okay. When you go out and get a job, your company knows you don't know much stuff. Because the company knows that you are new. They would train you. But what they want is that, are you able to learn? Are you able to pick up things fast? And the way to pick things up fast is that you ask questions and you try to make sense. Ask yourself, for these 4 questions, do you know what they are equivalent to? If you don't know, then I need you to do yourself a favor. Not do me a favor, do yourself a favor. Get this done by tonight. And by the time you come back tomorrow, same time, you'll be able to tell me like, oh, Mr. Chan, I know how to get these right. I can show you examples. I can explain to you how these works, how these will work in real life. So for the first one, a to the n power times a to the n power is equal to a to the m plus n. Again, the example that I gave people, that I gave you, was, look at this, a squared times a cubed. That's how many a's multiplied by itself. There'll be 5 of them. A squared is a times a cubed is a times a times a. There are 5 a's multiplied by itself, so it's a to the 5th power. If you don't have the justification, then you are going to confuse yourself. And this is a to the m minus n. All right? A to the m minus n power. So a cubed over a squared. Well, it's equal to simply a to the 1st power, because a times a over a times a, it's going to be just a in the numerator. A to the m, and then raised to the power of n, that's a to the m times n. A good example is this. Well, that's equal to a cubed times a cubed. You know what square means. Square means multiplied by itself. And that's how many a's multiplying together? How many? No. How would it be 9? A cubed times a cubed. There's a total of 6. Now, this is how you become a mature thinker. And how you will say goodbye to your naive version of you, because when you look at things like this, you exercise discipline, you exercise reasoning. You are not just going to say, oh, my brain just popped this idea, I'm just going to go with it. Your brain is going to pop you an idea and you verify it before you say something to embarrass yourself. And a to the m over n, that could be challenging. When it's a fraction, do you still remember the meaning of a fraction? If it's an exponent, what does the numerator mean? The numerator is not the root. That's the power. The denominator is the root. Again, your brain is going to give you some wild idea. And how do you know if it's right or not right? Now ask yourself, you know what's a squared? You know what's a squared, right? A times a. And you can look at this as a to the 2 over 1. 2 is the same thing as 2 over 1. So that's how you know. The numerator has always been the power since day one. So the denominator is the root. So if I have something like, oh yeah, what is a to the 2/3 power? Well, that's a squared. And then you put a cube root underneath it. Or something that's equally the same. It's you cube root the a and then you raise it to the second power. They are equivalent to each other. Okay, they have equal values. They're equivalent. Okay, you can take the root first and then square, and then or you can take the square first and then you cube root it. Either way. So before we head on to the next page, I need you to understand that this is crucial. If you do not know these basic properties of exponents, things are going to be pretty miserable. Okay, so I want to review this before we start.